We're going to be constructing addition table for modulo 3, modulo 4, modulo 5, modulo 7. So A, for modulo 3, the highest number would be 2. So the integer, the set of the remainders in modulo 3 will be 0, 1, 2. So that plus 0, 1, 2, 0, 1, 2. Okay, so 0 plus 0, we can either use the number circle or we proceed. So there's another circle. We're going to have something like this. Since it's modulo 3, and we are going to have 0, 1, 2. So 0, 0. There's something you need to know, because after we construct table for addition, I'm going to construct table for subtraction in subtraction also, or I'm going to construct subtraction table. Now, one thing you need to know is that for addition, first of all, there's what is known as the commutative property. Commutative property, and it means that order is not important. So what it means is, if you have 2 plus 3 or 3 plus 2, so whether 3 comes, whether 2 comes for 3 in this case, or 3 comes before 2 in this case, as long as it's addition, you get the same answer. 2 plus 3 is 5, and 3 plus 2 is 5. So this means that order is not significant. So we can say 2 plus 3 is equal to 3 plus 2. So this is what the commutative property means. Okay, so which means A plus B is equal to B plus A. So anyone that comes first, as long as addition, you're going to get the answer. It applies to addition table for modular arithmetic. So if we start by 0 plus 0, okay, it's going to be clear here. So if you have 1 plus 2, which means on this our number circle, start at 1, move 2 times. So from 1, 1, 2, we're going to end at 0. So 1 plus 2 is 0. But if you also start at 2 plus 1, that means start at 2, move once. So you see that it's going to arrive at 0. So you see, even in modular arithmetic, 1 plus 2 is equal to 2 plus 1, which is 0 equal to 0. So you see that addition is commutative. But when you are going to look at subtraction, you're going to see the difference. Subtraction is not commutative in the sense that 2 minus 3 is not equal to 3 minus 2. So 2 minus 3 is minus 1, 3 minus 2 is 1. You see that they are not equal. So I just have to bring this so that in subtraction, in modular arithmetic, if you are going to construct a subtraction table for modular arithmetic theory, you're going to have 2 separate tables. Why 2 separate tables? Because of order. So we're going to construct one that, assuming if modular theory, by the time we start constructing our table, if we're going to start from this side, the values from this side, which means maybe 1 minus 3, that is 1 minus any value here, or we start from the values here, that is the row, values on the row, these are columns. So we take values from here. So if you're taking values from here, this number must come first, the row must come first. If you're taking values from the column must come first. When we get there, I'll explain properly. So it's just, so when you get subtraction, we're having tables, 2 tables for each particular modulo. But for addition, we don't need 2 tables, because if you take your number from here and you add it to here, you get the same answer as when you take your first number from here and add it to, when you order it, like from here against this one or from here against one, you get the same answer. So we're going to be having one single answer table for each of the modulo here. So let's proceed. So 0 modulo 0 is 0. What this means that start at 0 and move 0 times. Move 0 times like don't even move, because it didn't give you any number of movements. 0 is like nothing. So 0 modulo 0 is 0 plus 0 is 0. So 0 plus 1 means start at 0, move once. 0 plus 1 is 1, and 0 plus 2 is at 0, you move 2 times, you stop at 2, you get 2. 1, okay, I think that's 0. Anyway, 1 modulo 0 starts at 1. 1 modulo 0 means 1 plus 0. 0 means nothing. 1 plus 0 start at 1, make 0 movement or make 0 turn. And making 0 turn is equivalent to making no turn or no movement at all. So 1 modulo 0 or 0 modulo 1 is 1. And then 1 modulo 1 start at 1, turn once or make one forward movement, and that will give us stop at 2. When you start at 1 and you turn 2 times or move 2 times, you get 3. 2 modulo 0 is 0. 2 modulo 1 is from 2. Move once, you have 0. Then from 2, remove once, 2 times plus 2 modulo 2. From 2, 1, 2. That's 1. So that's addition table for modulo 3. So we'll call this addition. There's the addition table. Addition table for modulo 3. Modulo 3. Another way to go about it is this. Now, when you get to this point, I think this answer is not supposed to be 1, because in modulo 3, the highest number is supposed to be 2. So let me work on this again. 1 modulo 2. So when you start at 1, move 2 times 1, 2 to 0. Good. So if you want to use the number circle, what you do is simply the way we've been resolving values, getting the modulo of a particular number. For instance, 3 in, let's say 5 in, let's say 5, convert 5 to a number in mod 3, that will give us 3 times 1 plus 2. 3 times 1 is 2. 2 times 1 is 3 plus 2 gives us 5. So 5 is 2 in mod 3. So if you don't want to use this number code or ring or circular movement, you can use this method. So for instance, 0, 0 in mod 3 is 0. 0 in mod 3 is 0. So all you need to do is you just fill up 0 mod 0 is 0, 0 mod 1, 0 plus 1 is 1, 0 plus 2 is 2, 1 plus 0 is 1, 1 plus 1 is 2. Now 1 plus 2, now this point, you see that 3, 1 plus 2 is 3, but 3 is equal to the mod we are carrying out this addition. So what we'll do is that we're going to reduce this, find the remainder. Once it gets to the mod number or exceeds the mod number, we're going to divide it by the mod number here, which is 3, and then get the remainder. So since 3 is the same thing as or equal to 3 here, we divide by 3. So 3 divided by 3 is equal to 1, remainder 0. So this is what we are taking. So this is what we do here. So then, so assuming it is let's say 3 plus 2, and we have to, okay, 3 plus, let's say 3 plus 3, and it's mod 6, or let's say mod, let's say mod 4. 3 plus 3 will give us 6. And in mod 4, the highest number is 3. So by the time you get to 3 mod 3, you're going to have 3 plus 3, which is 6. And you're going to put 6 there because in mod 4, the highest number is supposed to be 3. But now the addition, the result of the addition exceeds 3. So what you're going to do is that you divide 6 by the mod number, which is 4. So 6 divided by 4 is 1 remainder 2. So this is the 2 that you take. So 3 plus 3 is equal to 6, and 6 is equal to 2 in mod 4. So where when you are constructing the table, and when you get to 3 plus 3, this is what you're going to put, not the 6. B modulo 4 0 1 2 3 0 1 2 3. So I will not be using the ring. I'll just use the other method. So except we're told to use the ring or the number code in exam, because some questions can specify what method to use. So if the question doesn't specify, you can choose, but if the question specifies, please adhere to instruction. So 0 plus 0 will give us 0. 1 plus 0 is 1. 2 plus, remember this is mod 4. So your addition should not exceed 4. Once it exceeds 4 or gets to 4, divide by 4 and write down the remainder. So 2 plus 0 is 2. 3 plus 0 is 3. 1 plus 1 is 2. 1 plus 1 plus 0 is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1. So in this case, 3 plus 1 is 4, and this addition is in mod 4. So 3 plus 1 is 4. What you divide by 4, this is 1, then that's 0. You write your 0 here. And then 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2, 4 is 0. 3 plus 2, 5. 5 is 5 is greater than 4, and the highest supposed to be 3. So 5 divided by 4 is 1, remainder 1. So this one is what we have here. 0 plus 3 is 3. 1 plus 3 is 4. 4 in mod 4 is 0. 2 plus 3 is 5. 5 in mod 4 is 1. And 3 plus 3 is 6. 6 in mod 4 is 6 divided by 4 equals 1, remainder 2. So here's 2. This is addition table for modulo 4. The next is modulo 5, C plus 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. So let's proceed. 0 plus 0 is 0. 0 plus 1 is 1. 0 plus 2 is 2. 0 plus 2 is modulo 5, so it's not supposed to 5. This is 5. This number is 4. Okay, so the answer is 4. 0 plus 3 is 3. 0 plus 4 is 4. 1 plus 0 is 1. 1 plus 1, 2. 1 plus 2, 3. 1 plus 3, 4. 1 plus 4, 5. Since this is modulo 5, 5 divided by 5 is 1, and that's 0. 0 is 0. 2 plus 0, 2. 2 plus 1, 3. 2 plus 2, 4. 2 plus 3, 5, 0. 2 plus 4, 6. 6 in modulo 5 is 6 over 5, which is 1, remainder 1. That's 1. 3 plus 0, 0. 3 plus 0 is 3. 3 plus 1, 4. 3 plus 2, 5, 0. 3 plus 3, 3 plus 3 is 6, which is 1. 3 plus 4, 7. 7 in mod 5 is 7 over 5. 1 over 2, that is 2. 4 plus 0 is 0. 4 plus 1 is 5. 4 plus 2. 5 plus 1 is 5, so that is just 0 again. And here's 4. 4 plus 0 is 4. 4 plus 1 is 5. 5 in mod 5 is 0. 4 plus 2, 1. 4 plus 3 is 7, that's 2. 4 plus 4, 8. 8 in mod 5 is 8 divided by 5 is 1 over 3. That's 2. So this is addition table for modulo 5. Let's get modulo 7. Modulo 7 plus 0, 1, 2, 3, 4, 5, 6, 0, 1, 2, 3, 4, 5, 6. So 0 plus 0 is 0. 0 plus 1, 1. 0 plus 2, 2, 3, 4, 5, 6 is 1. 1 plus 1, 2, 3, 4, 5, 6. 1 plus 6, 7. And this is mod 7. So 7 in mod 7 is 1 looking at 0. 2 plus 0 is 2, 3, 4, 5, 6. 2 plus 5 is 7, which is 0. And 2 plus 6 is 8. 8 over 7 equals to 1. Remember 1. So there will be 1. 3 plus 0 is 3. 4. 3 plus 2, 5. 3 plus 3 is 6. 3 plus 4, 0. 3 plus 5, 1. 3 plus 6, 9. 9 divided by 7 equals to 1 omega 2. Here will be 2. 4 plus 0, 4. 5, 6, 0, 1, 2. That will be 3. 5 plus 0 will give us 5, 6, 0, 1, 2, 3, 4. And here will be 6, 0, 1, 2, 3, 4, 5. This is addition table for modulo 7. Okay, so we have completely constructed addition table from what we have here from A to D, modulo 3 to 7, 3, 4, 5, and 7 instead. So the next one says simplify the following from the tables. So A, we'll come here, says solution. Let's say A, E, 3 plus 2, 3 plus 2 mod 4. Remember the question says from the tables that we have constructed. So let's look at mod 4 table. This is the table. So 3 plus 2 means start. This is where we're starting. So this is we are going to follow the order 3, which means from here either we take 3 here, we start with 3 and then we look for 2. 3 plus 2, or yeah, so since 3 came first, 3 plus 2, then we'll trace it to where we have 3 column here, that's 1. So 3 plus 2 down to here, 3, you bring it down here. This is the column where 3 is. Bring it down and then bring this on here where they need this box as the answer. So 3 plus 2, 3 plus 2 is equal to 1 mod 4. B says 5 plus 3 mod 7. So 5 plus 3 equals so let's look at mod 7. 5, the order is 5, so we'll come to here, start with 5. 5 plus 3, then here is 3, come down to where we have 3, this is 3, that's 1. 5 plus 3 is 1 mod 7. We can also come here and say, look at where we have 5, we also have 5 here, 5 plus 3, and then we'll come down and see, we also have that 1, so it's the same. If it's not the same, that means there's something wrong with how we filled the table, so it must be the same. Similarly, also here, as we looked at 3 from here, we can also look at 3 from here. 3 plus 2, so 3 plus 2, so bring it down. What do we have here? 1, just as 3 plus 2, here's 1. 3 plus 2, here's 1. So actually the answer is correct. C. 4 plus 2, 4 plus 2, this is to be done in mod 7. So mod 7, 4 plus 2 is equal to, so mod 7, 4 plus 2, so bring it down to where you have 4, that's 6. 6, 4 plus 2 is 6 in mod 7. The same way, if you start from 4 here, 4 plus 2, trace it down, 6. And D is 4 plus 2, 4 plus 2 in mod 5. 4 plus 2 in mod 5. So 4 plus 2 in mod 5. This table is 4 plus 2. Bring it down. That's 1. It's equal to 1 mod 5. Well, if you decide to get your 4 here, then that will be 4 plus 2. Take it down here. That's 1. So it's correct. E is 4 plus 4 plus 3. This is E 4 plus 4 plus 3 will be done in mod 5. So what I'm going to do is that we're going to simplify. First of all, we're going to get 4 plus 4. Okay, let's do it this way. I'm going to enclose it in brackets so that's easy for us. So this will give us 4 plus 4. We do this as a unit first, and plus 2 plus 2, all in mod 5. So that's what we're going to do. So let's get 4 plus 4 in mod 5. 4 plus 4. And that's 3. Or we say 4 plus 4. That's 3. So this will give us 3 plus 2 in mod 5. 3 plus 3. Bring it down. That's 1. 3 plus 1. 3 plus 1. This will be also in mod 5. So this is a simplified form of what we have here. 3 plus 1 in mod 5. 3 plus 1 is equal to, so 3 plus 1. And what do we have? It's 4. So the answer is 4 mod 5. That's your answer. And now we're going to construct subtraction table for the following. Modulo 4. So E. Now in E, we're going to have two variants. So, and that is because of order. I explained earlier that in subtraction, order is important because subtraction is not commutative. Subtraction does not commutative principle or property does not apply to subtraction. So what we're going to do is that for modulo 4 subtraction, we're going to have subtraction 0, 1, 0, 1, 2, 3, 0, 1, 0, 1, 0, 1, 2, 3. Okay, so this is what I was trying to say. Now we can also use another circle, or we can use the other method. So now I told you earlier that 0, let me come here. 0, if you have 2 minus 1, 2 minus 1 and 1 minus 2, they are not equal because 2 minus 1 is 1, 1 minus 2 is minus 1, so both of them are not equal. Therefore, subtraction is not commutative. So because of this, order is important. So if you're going to, if it says 2 minus 1, so if you are going to start here, 2 minus 1 is not the same as 1 minus 2 when it comes to subtraction. So you have to be consistent with the order. So if you want to fill this table and you want to pick your first number from the row, from the column, so against the row, you must be consistent with that all through. But if you want to pick your first number, which is 2 from the row here, so 2 minus 1. So if the next one is 1, it's a 3, okay, 2 minus 2. If the first one is 2 minus 1, you started with 2 here minus 1. The next one, 2 minus 2, you should come and say 2 minus 2, and then you trace it down. No, it should not be correct. So say 2 minus 2. Repeat it here. So because by the time we start constructing the tables, the different tables, and we come back to this, you'll see that 2 minus 2, which is something, the value will be here, will not be the same as 2 minus 2, the same value that will be here. So let's first of all fill up this table. So here 0 minus 0 is 0, and then okay, I'm going to start with my rows. So 0 minus 0 is 0, 0 minus 1. Now 0 minus 1 from your arithmetic, 0 minus 1 is equal to minus 1. And we are carrying out this operation in modulo 4. So this will give us 4 times minus 1. What would be, this is minus 4, will be added to minus 4 such that our answer will be minus 1. So 4 times minus 1 plus 3, that will give us, so minus 1 is 3 in mod 4. But when it comes to subtraction, I think this will be a bit slow, so I'm going to use the circular movement. So since in mod 4, we're going to have this, I'll prefer this for subtraction. So here will be 0, here is 1, 2, and 3. And I told you that when we are using the circular tone or the number code for subtraction, it's going to be backward movement. You know, when we're doing addition, we moved from 0 to so on. So it was a clockwise movement. But for subtraction, it's going to be anti-clockwise movement. So let's prove this. 0 minus 0 means start at 0, but there's no movement because 0 minus 0. So start at 0 and move 0 times. So that's 0. So that's it. 1 minus 0 means start at 1, move backwards 0 times. So that will give us 0. 1 minus 0. So start at 1, Now, it all depends on where I am starting. If you say 1 minus 0, which is 1 minus 0, start at 1, move 0 times. So move backwards 0 times. That means there's no movement, so it will be 1. Okay, so here 1 1 minus 0. 0 minus 0 is 0. 1 minus 0 rather is 1, correct? So 1 minus 1, I've not got to this point, which is 0 minus 1. So that would be another order. So 1 minus 1 means start at 1, move backwards once. So that would be 0. 1 minus 1 is 0. 1 minus 2, start at 1, move 2 times backwards. 1, 2. That would be 3. And then 1 minus 1 should be here. And confuse myself. So start again. So 0 minus 0 is 0. 0 minus 1. Let me should have come like this. 0 minus 1. Start at 0. Move once. 0 minus 1 is 3. 0 minus 2. Start at 0. Move backwards 2 times. 1, 2. So 2. 0 minus 3 will be 1. Then 1 minus 0. Start at 1. Move 0 times. So it will be 1. 1 minus 1. Start at 1. Move once. That will be 0. 1 minus 2. Start at 0. 1, 2. That's 3. 1 minus 3. Start at 1. 1, 2, 3. That's 2. So 2 minus 0. When you start at 2, move backwards 0 times. That is 2. 2 minus 1. From 2 once, that's 1. 2 minus 2. From 2, 1, 2. That's 0. 2 minus 3. From 2, 1, 2, 3. 3. 3 minus 0 will be 3. 3 minus 1. From start at 3, move once, that's 2. 3 minus 2. From 3, 1, 2, 1. 3 minus 3 minus 3. So from 3, 1, 2, 3, 0. So this is subtraction. This is the first variant, modulo 4. Second variant will be, and this first variant, remember, the order was from this, like this first number. I started my subtraction from the row. So the next table for modulo 4 would be, I'm going to start my subtraction. The first number will be taken from the colon. So it will be 0 minus the number here. So let's bear in mind. And like I said, any part you choose to use first, be consistent, because subtraction is not commutative. Therefore, if you are using 1 minus 1, the answer will not be the same as 1 minus 1. Next variant would be minus, it will be 0, 1, 2, 3, 0, 1, 2, 3. So I'm going to start from here. 0 minus 0, 0. 1 minus 0. So 1 minus 0 means start at 1, but don't make 0 move. 0 move is equivalent to nothing. So it's 1. 1, no, 1 minus 0. 1 minus 0 is 0. 1 minus 0 is 0. 1 minus 1. 1 minus 1 is from 1. Move backwards. That's 0. So 1 minus 2 from 1. backwards 2 times 1, 2, 3, 1 minus 3 from 1, 1, 2, 3, 2, 2. So 1 oops. Right done. Okay. 0, I was supposed to start with 0. 0 minus 0 is 0. 0 minus 1. So from 0 backwards, 0 minus 1 is 3. 0 minus 2. From 0, 1, 2, 2. 0 minus 3. From 0, 1, 2, 3, 1. So 1 minus 0 from 1. Now we give 1. 1 minus 1 from 1 backwards 0. 1 minus 2 from 1, 2. That's 3. 1 minus 3. 1, 1, 2, 3. That's 2. 2 minus 1. 2 minus 1 would be from 2 backwards 1. So 2 minus 0 is 2. 2 minus 1 is 1. So 2 minus 2. 2 minus 2 be from 2, 1, 2, 0. 2 minus 2 minus 3. So 2, 1, 2, 3. That's 3. 3 minus 0 is 3. And 3 minus 1. So from 3 move backwards in anti-clockwise direction. That's 2. 2. 3 minus 2. That's from 3, 1, 2, 1. And 3 minus 3. 3 minus 3. 1, 2, 3. That's 0. So now let's compare. So from our table here, we said 2 minus 1 is not the same as 1 minus 2. So from our table, 2 minus 1 means 2 comes first. So let's see where 2 comes first. 2 minus 1. Let's bring it down. That's 3. So if 2 minus 1 is 3, so let's also see 2 minus 1. Come here, this is 1. You see that 2 minus 1, 2 minus 1, bring to where you have 2, you have 1, and 2 minus 1, here you have 3. Okay, let's see. Minus 1, 2 minus 1, 2 minus 1, 1, and then 2 minus 1, you have 3. So you can see that the order matters. Same order here. So if you are starting with 2 on this row, and then you locate 1 on the column, and then you find where it meets, you discover that if you follow the same pattern here, you get 1, 1. But if you go the other way around, you get 3, 3. So this is why if it's subtraction, you follow your order. So in this particular case, you see that 2 minus 1. If I follow in this particular here, I said that with this. So if I go with here 2 minus 1, what do I have here? Is 1. So 2 minus 1 is 1. But if I go with 1 minus 2, in other words, I'm going to start with 1. 1 minus 2 is 3. So what do you have here? 3. And 1 minus 2 is minus 1. And what is it? 3 and not 4. Let's come here. 2 minus 1. 2 minus 1 is what? 3. This is the reverse. So which means in this particular case, the order was 1 minus 2. So we should start here 1 minus 2, which is 3. But if you go by 2 minus 1, which means 2 minus 1, 2 minus 2 minus 1, which should be 3. So this implies that for subtraction, you don't just start off to do what you like. You must determine which of what number is going to come first, and once you choose that number, be consistent with it when constructing a table. So what I mean is, If you have already outlined your numbers with your numbers on the row box and on the column box, if you're going to start picking a number from here, the first digit 0 minus 0, the next one will be 1 minus 0, start up until you fill up the table like that. Don't jump from here 1 minus 1 and then the next one is answer 2 minus 1. Your answer will be wrong and your table will be wrong. It's going to affect your answer. Whatever you're going to do with this table is going to affect it. So let's construct the next table. Modulo 6. Let's say subtraction table from modulo 4. Minus 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. Okay, so for B, I'm going to start with the row. So 0 minus 0 is 0. 0 minus 1 means start at 0, move once backwards. Since it's minus, I'm moving backwards once. That's 5. 0 minus 2, move backwards 4. 0 minus 3 would be 3. 0 minus 4 would be 2. 0 minus 5 would be 1. Let's see. 0, 1, 2, 3, 4, 5, 6, 1. So 1 minus 0, from 1, you move 0 times is 1. 1 minus 1 would be from 1, you move backwards, that's 0. 1 minus 2, from 1, you move backwards 2 times, that's 5. 1 minus 3 would be 1, 2, 3, that's 4. 1 minus 4 would be 3. 1 minus 5 would be 2. 2 minus 0 is 2. 2 minus 1 from 2 as 1. 2 minus 2 from 2. 1, 2, 0. 2 minus 3 as 2 minus 3 from 2. 1, 2, 3. That's 5. 2 minus 4. 1, 2, 3, 4. 4. 2 minus 5. 2 minus 5 would be from 2. 1, 2, 3, 4, 5. That's 3. Okay. So 3 minus 0 is 3. 3 minus 1 from 3. That's 2. 3 minus 2 would be 1, 0, 5, 4, 4, 3, 2, 1, 0, 5. This would be 5, 4, 3, 2, 1, 0. So that's when we start off this from the row. So let's get from the column minus, so let's say minus 0, 1, 2, 3, 4, 5, modulus 6, 0, 1, 2, 3, 4, 5, Okay, so now we are using this part. So 0 minus 0, 0, 0, 0 minus 1. So from 0, we move backwards. 0 minus 1, 0 minus 1, that's 5. 0 minus 2, from 0 minus 2, 4. 0 minus 3, 3. 0 minus 4, 2, 1. 1 minus 0, from 1, that's 1. 1 minus 1, 1, that's 0. 1 minus 2 from 1, 1, 2, that's 5. 1 minus 3 from 1, 1, 2, 3, 4, 3, 2. 2 minus 0 is 2. 2 minus 1, 2 minus 1 from start at 2 move once, that's 1. 2 minus 2 would be from 2, 1, 2, 0. 2 minus 3, that would be 5, 4, 5, 4, 3. 3 minus 0 is 3. 3 minus 1 from 3, that's 2. 3, that's 1, that's 0. 5, 4, 4, 3, 2, 1, 0, 5, 5, 4, 3, 2, 1, 0. So that's it. This is subtraction table. This and this is subtraction table. And this is subtraction table for modulo 6. So which of them you should construct and which of them you should use depends on how the question is presented to you. Theory by theory, mod 4. So in this case, this is theory, this is theory. If it's mod 4, which of them is it? The row you should use, the column? It all depends on you. So all that matters is that you should be consistent. If you are using the row, make sure every that's problem and everything you do on that table should just follow that manner and you get the same result. So what if in an exam condition the question given to you maybe subtraction like this, but the examiner got his table by using the row first against the column, but when you constructed your table you started off with the column against the row. Well, the examiner also knows that when it comes to subtraction there are variants. It's not like addition that's commutative. So whether you start with 0 before 1 or 1 before 0, you get the same answer. The examiner knows that for subtraction, it's not going to be like that. So there will be provision for that other option. So you just have that at the back of your mind. So let's solve the questions we have here. On your tables, evaluate a 3 minus 3 in mod 4. So in 3 minus 3 in mod 4, where do we have mod 4 here? So if we're going to start with the row, that means we come here. This was where we started with the row. So let's come here. 3 minus 3. That's what? 0. So 3 minus 3 is 0 in mod 4. So 3 minus 5. 3 minus 5. 3 minus 5, that means the 3 minus 5 is less, the number here is less than 5. That will give us a negative value. So from also another way to confirm your answer is also by using number circle, but I don't want to go to that. So 3 minus 5, we have from here. So 3 comes first before 5? 3 minus 5. So if we go by 3 minus 5 multiple, we have 3 minus 5. 3 minus 5 come down, that's 2. 2, that's 2. So 3 minus 5. If we square, that's 2 mod 5. That's if we use this row against the column. But if it is the other variance, that if it is 1, 3 minus 5 will be 3 minus 5. You can see that it will be 4. So the examiner knows that. So either 2 or 4, but let's pick 2 mod 6. So 5 minus 3. Okay. So 3 minus 5 mod 6. This mod 6, let's confirm our answer. So we need to start at 3, move backwards 5 times. So 3, 1, 2, 3, 4, 5. So it's 4. So which means it's this construction that was used. So let's get this one. 3 minus 5 would be 3 minus 5 is 4. So the answer is 4. Confirmed. So I would suggest that we always use a number circle to confirm your answers. So now let's look at this 5 minus 3. Let's see. First of all, let's look at this one, 5 minus 3. So let's see. Here we started with the rule. So 5 minus 3 got 5 minus 3, so that's 2. So right here, started with this part against here. So 5 minus 3 come down, that's 2. 5 minus 3 is 2. And here with the rule, 5 minus 3 is 2. So let's see what our number circle gives us. 5, start at 5, move backwards to 3 times. So 1, 2, 3, correct, that's 2. 5 minus 3 is 2 mod 6. Okay, I think maybe this reason why I got conflicting answer here is because I need something 3 minus 5. So since I started with 2 here, 3 minus 5, 3 minus 5 is 4. So the answer is 4. So even with here, the answer will still be the same. But to check, use your number circle to check. 2 minus 3 mod 4. Let's still see how this applies with mod 4. 2 minus 3 is equal to mod 4. 2 minus 3, 2, 2, 2. Where is 2? 2 minus 3. Bring it down, that's 1. So 3, 2 minus 3, 2 minus 3 is 1. So also come here, 2 minus 3, 1. Okay, so there's 1 mod 4. So to be consistent with your answer, first for this particular example, 2 minus 3, any of the variants you use, you're still going to get the same answer, provided you follow the order that is given. So if you use this variant, 2 minus 3, that means you come here, 2 minus 3, 2 minus 3, you trace it down to where you have this. And what is it? 2, that's mod 4. It's mod 4. So in mod 4, 2 minus 3, bring it here, is 3, and then here, 2 minus 3 is 1, and here 2 minus 3, you have 1. So if you come here, 2 minus 3 is 1. So you get some answer. So here 3 minus 2 mod 4. So 3 minus 2, come here, 3 minus 2, that's 1. 3 minus 2, 1. And then we come here, 3 minus 2, 1. Okay. And next one, 5 minus 2 mod 6. 5 minus 2 mod 6. So mod 6, 5 minus 2. 5 minus 2 is 3. And then 5. 5 minus 2 is 3. 3 and mod 6. 1 minus 3 mod 4. 1 minus 3 is 2. Then we come here. 1 minus 3, which is 2. Yes, that's 2 mod 4. So arrange the days of the week: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday on a circle using the number code 0 for Sunday, 1 for Monday, 0, 0, 1, 2, 3, 4, 5, 6. That's the code. So 0 stands for Sunday, Monday 1, Tuesday 2, on and on till Saturday, which is 6. So if today is Thursday, so if it's Thursday, Sunday, Monday, Tuesday, Wednesday, Thursday, 4. Which day will it be in 5 days time? So if in 5 days time, I will be in 5 days time it will be from 4. Start at 4. We'll move in the clockwise direction. Move in clockwise direction 5 times. That will be 1, 2, 3, 4, 5, 2. And 2 is Tuesday. So in 5 days time, 5 days time will be Tuesday. 5 days time will be Tuesday. 5 days time will be Tuesday. Says 10 days time. So for 10 days time, 10 days time starts at Thursday. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that will be 0 on Sunday. So 10 days time will be Sunday. See, 7 days time. 7 days time will be 7 days time. We start from 4, which is Thursday. Will be 1, 2, 3, 4, 5, 6, 7. 7 days time will be Thursday. And D, 39 days time. 39 days time. Since our counting is in 7, because 7 days make a week, so from Thursday 7 times 39, this is in mod 7, so 39 in mod 7 because it's 7 times 5, which is plus 4. So 7 times 5 is 35. So if you go around the circle 7 times, you still stop at, if you start at Tuesday, Thursday, go around this circle 7 times, go around this circle 5 times rather, you get 35. That's 35 days from Thursday, which is 4. So the remaining 4 days will be 35 plus. So let's assume we've gone around this circle 5 times. So now we need to count the remaining 4. So from here, 1, 2, 3, 4. That's 1. So to be Monday, technically 39 days time will be Monday. So using the code for days of the week given in previous question, answer the following. So A. So in the previous question, we used this code. This is 0. Here 0 is for Sunday, 1 Monday, Tuesday, 2 Wednesday, Thursday, Friday, and Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, 6 Saturday. So if today is Tuesday, what day will it be? 19 days time. So 19 days time, 19 is 7 times. This mod 7. 19 days time will be 7 times 2. 7 times 2 is 4 plus 5. So 19 days time, 19 days time will be, will come here. I mean 7 times 2 is 14. So from, if you start to add it, so this Tuesday. So Tuesday is 2. That means if you go around the circle 2 times, that's 14 days. So from Tuesday, count the next 5 days. That's from here 1, 2, 3, 4, 5. That's that will be Sunday. So 19 days time will be Sunday. Yeah. This says express 2 and 19 as numbers mod 7. 2 and mod 7. 2 as mod 7. 2 as mod 7 is just 2. 2 is equal to 2 in mod 7, and that's the best way to write it. 2 is equal to 2 in mod 7, and then 19. 19 is equal to 7 times 2 plus 5. So 19 is equal to 5 in mod 7. C. Express 2 and 19. Calculate 2 plus 19 in mod 7. 2 plus 19 in mod 7. 2 plus 19 is 21. 21 to 2 plus 19 equals to 21. So 2 plus 21 equals to 7 times 3, and that's 0. So that would give you 7 and 3 is 0. So 21 is equal to 0. So that's also what we got here. And 0 is Sunday. So 19 days, if it is Tuesday, 19 days 19 days after Tuesday, if it is Tuesday, what day will it be in 19 days time? So 20. If you look at C here, 2 plus 19 minus 7 is 21. In multiple of 7, that's closest to 21. 7 times 2, which is 21. So 21 divided by 7 is 2, and then that's 0. So 21 is 0. And remember, 0 stands for a code. A day here is a code for a day, and that day is Sunday. And that's what you have here. So D. This is, does your answer in part C confirm your answer, your result in part A? Part C, 2 plus 19, when you solve it as in mod 7, you get it. That's you get the same thing as what if you solve this in statement form. So the answer is yes. How? In 19 days time will be Sunday. If you use the number code, if you rotate 19 days time, so from today's Tuesday, so from 2, so 19 days with 7 times 2 plus 5, so 7 times 2 is 14. So go around this circle 14 times, which is 2 in 7, that's 2 times. That will use 14. So the remaining 5 days, you count it from Tuesday, which is 1, 2, 3, 4, 5, which is 0. And here 21 is equal to 7 times 2, that's 0, which is 21 equals to 0, and 0 is for Sunday. So the answer is yes. This is our clock. 12, 6, 3, 9, 1, 2, 4, 5, 7, 8, 10, 11. So we're told that the shorter hand points to 10. Now, the question says the shorter hand of the clock points to 10. What number did it point to 29 hours ago? So 29 hours ago means that it's going to go back in the opposite direction. So that's anti-clockwise direction. So 29 hours ago, on back like this. Clockwise is this way, anti-clockwise is like so. Something about 29 hours ago past. So and from 10, if you rotate backwards if you start from 10 and move backwards until you get to 10, that's 12. And if you do that again, that's 2 times, that's 24. And so you are left with 5 more extra, so 24 plus 5. That's like 12 times 2 plus 5, which is the 29 minus 29. That's 12 times minus 2 plus 5. So if you go back, remember minus means backward movement. So, or anti-clockwise movement. So if you take anti-clockwise direction or turn in anti-clockwise direction 2 times, you get 24. So let's assume that we have done that 2 times. So we are left with 5. Let's count backwards 5 times. 1, 2, 3, 4, 5. That's 5. So 29 hours ago, what number did it point to? It pointed to 5. It pointed to 5 29 hours ago. It pointed to 5 29 hours ago. B. Find the simplest positive form of minus 29. Minus 29 in mod 12 is equal to minus 29 equal to 12 times minus 3 plus 12 times minus 3 will give us minus 36. What will be added to minus 36 to give us minus 29? That will be 7. 7 minus 36 plus 7 will give us minus 29. So plus 7. So therefore, minus 29 is equal to 7 in mod 12. C. Calculate 10 minus 29 mod 12. 10 minus 29 in mod 12. 10 minus 29 is equal to minus 19. And minus 19 is equal to, in mod 12, minus 19 is equal to 12 times minus 1 plus 12 times minus 1 will give you 12 times minus 2. 12 times minus 2 is minus 24. What will be added to minus 24 to give us 19? That will be 5. So minus 19 is 12 times minus 2 plus 5. Therefore, minus 19 is equal to 5 in mod 12. So D. Does your answer in part C, which is part C is minus 19 is equal to 5, confirm your results in part E? Part E is okay, it pointed to 5 29 hours ago. Yes. So in part A, the answer is 5, and in part C, 10 minus 29 is 5, which means that if the shorter hand of the clock points to 10, which means starts at 10, minus 29 means it moved backward in anti-clockwise direction 29 times. So it's going to stop at 5, which is it. So our answer here is yes.